Good morning to all. I am Dr.B.Angelin, Assistant Professor, Department of Information Technology, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to discuss about the topic memory management in operating system. What is a memory management in operating system? Memory management is the functionality of an operating system which handles or manages primary memory and moves process back and forth between main memory and disk during execution. It is the most important functions of an operating system that manages primary memory. It helps process to move back and forward between the main memory and execution disk. It helps operating system to keep track of every memory location irrespective of whether it is allocated to some process or it remains free. Moreover, to increase performance, several processes are executed simultaneously. Why using a memory management? Here some reasons for using memory management. It allows you to check how much memory needs to be allocated to process that decide which processor should get memory at what time. Tracks. Whenever inventory gets a feed or unallocated, according to it will update the status. It allocates the space to application routines. It also makes sure that these applications do not interface with each other. It helps protect different processes from each other. It places the programs in memory so that memory is utilized to its full extent. The next one is partition allocation. Memory is divided into different blocks of partitions. Each process is allocated according to the requirement. Partition allocation is an ideal method to avoid internal fragmentation. Below are the various partition allocation schemes. The partition allocations are first fit, best fit, worst fit and next fit. First fit. In this type, fit the partition is allocated which is the first sufficient block from the beginners of the main memory. Second one is the best fit. It allocates the process to the partition that is the first smallest partition among the free partitions. The next one is worst fit. It allocates the process to the partition which is the largest sufficient freely available partition in the main memory. The last one is next fit. It is the mostly similar to the first fit, but this fit searches for the first sufficient partition from the last allocation point. It allows you to check how much memory needs to be allocated to process that decide which processor should get memory at what time. Next one is memory management techniques. Single contiguous allocation, partition allocation, paged memory management, segmented management. Single contiguous allocation, it is the easiest memory management techniques. In this method, all types of computers memory except a small portion which is reserved for the operating system is available for one application. For example, the Microsoft DOS and embedded operating system. Partition allocation. It divides a primary memory into various memory partitions which is mostly contiguous area of memory. Every partition stores all the information for a specific task or job. This method consists of allotting a partition to a job when it starts and unallocated when it ends. Paged memory management. This method divides the computer's main memory into fixed size units known as page frames. This hardware memory management unit maps pages into frames which should be allocated on a page basis. Segmented memory management. Segmented memory is the only memory management method that does not provide the user programs with a linear and contiguous address space. Segments need hardware support in the form of a segment table. Swapping. The swapping is one of the main topic in a operating system. It means the swapping the processor. Swapping is a method in which the process should be swapped temporarily from the main memory to the backing store. It will be later brought back into the memory for continued execution. Backing store is a hard disk or some other secondary storage device that should be big enough in order to accommodate copies of all memory images for all users. Here are major benefits pros of swapping. Fragmentation. As a process or loaded and removed from memory, the free memory space is broken into little pieces. It happens often sometimes that processes cannot be allocated to memory blocks considering their small size, and memory blocks remains unused. This problem is known as a fragmentation. Paging. The paging is a technique that eliminates the requirements of contiguous allocations of main memory. In this, the main memory is divided into fixed size blocks of physical memory. It's called a frames. Segmentation. Segmentation is a technique that eliminates the requirements of contiguous allocations of main memory. Thank you.